In our assumptions, we defined that the checkbox with the information that the given task is finished will be displayed. To do so, we have to create our own layout, which includes a checkbox. The new layout will have the name todo_item. We'll create a linear layout which will include a checkbox. If we decide to use this layout in our adapter, we'll pass our layout as the second parameter. Brace yourself for an unpleasant surprise. The application closes. The error that caused the end was the attempt to cast a linear layout to a text view. This is because in the default implementation, Array Adapter assumes that the past layout is composed only from text. We can work around it by using the second available constructor. In this constructor, apart from providing a layout, we also provide a place in the layout where we can find a text view which we can set the text on. The checkbox inherits from text view, so the implementation is correct. Below, the array adapter searches for a certain text view to be set, and then it sets the text obtained from the toString method called on the object stored in the collection. That's why, in our case, each todo element has a called toString method, and then the string is set on the text view object. We'll test the version with the checkbox. After refreshing the data, the checkboxes appear and the elements have a set text. However, here there is no information about selecting the checkbox, and the displayed text is a toString. If we wanted for the done flag to affect whether the checkbox is selected or not, and for the content to be displayed as the main text, we'd have to expand the implementation by overriding the getView operation, in which the entire process for creating a view based on a model is carried out. The getView method has three parameters: position, convertView, and a group of views which are a parent. In a moment, I'll tell you what these parameters are for. Now, we'll begin by showing how to create the view that should be returned. We skipped the default implementation of the getView method to see what the operation of this method looks like and how to implement our own ideas from scratch. We begin by creating a view. In order to create this object based on the XML file we have, we need a layout inflator. We can get it in the array adapter by calling the getLayoutInflator method. Then we call the inflate method on it, passing the layout which we want to process to a view. We pass the root, that is the object inside which the view has to be nested, as the second parameter. In our case, it is nothing more than a parent. The last parameter is the information about whether we want to automatically attach the view to the root. As it will later be carried out by the adapter, we don't want to do this now. Such a view can be returned, but before it would be good to set specific values. We have a view that is a linear layout inside which is our checkbox. Because of this, in order to get to the checkbox, we use the find view by ID method. However, this time we don't call it on an activity, but on a view. Having an extracted checkbox, we can set, for instance, a text and a flag there. However, first we need the data. We can extract it using the getItem method and passing its position. This is a variable which specifies the position in the collection we're in. It allows us to extract data from the model. We assign the data to the to-do object. Now, we can set the relevant fields on the checkbox. We set to-do content as set text and to-do done as set checked. We refresh our list and get the desired effect. Our content is set as text, and the done flag is used as a selection. Everything looks all right, but there are two problems with this solution. First of all, this solution is not efficient for two reasons. Each time we create a new view, we have to do the entire view building in the form of an XML file. Each time a particular element is displayed, we have to create a view from the XML file from scratch. This process is very time-consuming. Because of this, each call of the inflate that we can avoid is a huge gain. That's why the convert view mechanism was used. Its principle of operation is that views which are built once land on the list. If the list is scrolled and the views are no longer visible, they are left to be used for later to create the element when it appears. If it's a view of the same type, there is no problem in using it again without the need to create it from scratch. That's why usually if we have 10 elements visible simultaneously, we'll have these 10 elements on the list along with possibly 2 additional ones which will be needed when scrolling. Thanks to this mechanism, the number of inflate calls needed to scroll the list decreases significantly. As a result, scrolling the list is much smoother. In order to use this possibility, we have to assign a convert view to the view and perform a check. If the view is null, or in other words, there is no view of such a type in the view pool, we have to assign an inflated value to the view. Such a solution automatically gets rid of numerous and unnecessary inflate executions. However, it doesn't protect us against the second problem. Each time when using the view, we have to call the find view by ID method. This method searches the entire hierarchy. So, if we have many views inside our layout, it's extremely time-consuming. To limit the number of Find View by ID calls, Google suggested a solution under the View Holder title. It's a simple pattern consisting of a newly created class whose task is to store references to the views inside the layout. In order to use the View Holder, we need to create a new class to store the specific views we're interested in. In our case, we need the checkbox. Now we create a new View Holder object and assign values extracted using Find View by ID to it. Later, we'll use only this object. In order to avoid repeating everything each time, we store the View Holder together with the references in the object we want to return. In our view, we have the setTag method, which allows us to store any object inside the view, in our case, the layout. We put our View Holder inside. At the next call, it will already be put inside the Convert view. If we return and it turns out that the view getTag returned something that isn't a null, we can already do that. However, if it is a null, we must create a new instance and save the extracted elements. Actually, this is the moment we create the View Holder and assign it. From now on, we'll have to call the Find View by ID option only the first time we create a new view. In all remaining situations, when using a view returned to us, such a view will have its View Holder already remembered. So we'll have direct access to all the cells inside the view. Using these two methods allows for an easy improvement of the list performance and smoother scrolling, particularly in the case of large and difficult views displayed on the list. We check the application once again, and after the refresh, everything works correctly. We can now move on and deal with saving and reading data to and from the database.